Hello and welcome to Binary Basics by Jason Colhan. Today we're going to learn how computers communicate. Every day we use computers for various activities. These activities range from checking email, surfing the web, and creating documents, and many more activities. What I'm going to do is teach you the basics behind how computers communicate in order to get this information across. We'll start out with a bit. What is a bit? A bit is a 1 or a 0 representing an on or an off signal. These are how the computer generates numbers. When you string 8 of these together, you get a byte. A byte is representative of a number. This can be any number from 0 to 255. The placement of a bit inside of a byte, the 8 characters, tells us the value. This ranges from 128 down to 1, starting actually on the left with 128. You have the first bit at 128, second at 64, the third at 32, the fourth at 16, the fifth at 8, the sixth at 4, the seventh at 2, and the eighth at 1. Now, how does this work is where we get a little more advanced. We'll go into practicing the binary. We'll start with a number of 167 and see if we can't determine what it is that the binary value would be for this decimal number. We start out with the first number, with the first bit. The first bit is 128. 167 does subtract 128 down to 39, so therefore this bit is on. The next bit is 64. 39 cannot subtract 64, so the bit is off, giving us a 0. So far we have a 1 and a 0 and 6 more bits that we don't yet know. Next bit is 32. 39 does subtract 32, giving us 7, leaving us with 1, 0, 1, and 5 more bits that we need to find out. The next bit is 16. 16 cannot be subtracted from 7, so the fourth bit is off, which gives us 1, 0, 1, 0. We're halfway there. The fifth bit is 8. 7 cannot subtract 8, so the bit is off, leaving us with 1, 0, 1, 0, 0, and 3 bits we're still looking for. The sixth bit is 4. 7 can subtract 4, which gives us 3, which means the bit is on. So 1, 0, 1, 0, 0, 1. The seventh bit is for 2. 3 can subtract 2, leaving us with 1. So the bit is on. And lastly, we have the bit for 1. Now remember, we're down to 1, so 1 minus 1 is 0, and that's definitely our last bit. So we come down to 1, 0, 1. 0, 0, 1, 1, 1. So that is our binary version of 167. But we're not done yet. We have to verify that this is correct. The way this works is you take the original scale that I gave you, showing which bit is for which value. Then we change the top values to match the binary that we've already come up with. We drop this down and you get 128, adding 32, adding 4, adding 2, and adding 1, which comes out to 167, which means that we have been successful. Thank you for your time, and thank you for paying attention to this presentation.